Hey everyone, it's Miss B, and in this video we're looking at the Unit 6 Lesson 12 cumulative practice problems for illustrative math geometry. So let's jump into it. For each equation here, we want to know, is the graph of the equation parallel to the line shown, perpendicular to the line shown, or neither? And we should have 6 answers. So the first thing I'm going to do here is actually find what is the slope of the line that I have shown. So I'm going to identify 2 points, which are going to be these two right here. And just kind of count what my slope is. So it looks like I'm going up 1, and then we're going to the right 1, 2, 3, 4, 5. So up 1 over 5, and since we have rise over run, that means that this slope is 1 over 5, or 0.2. Okay, so that means we can start answering these questions. Parallel would mean that the slopes are the same. Perpendicular would mean that the slopes are opposite reciprocals, meaning opposite in basically both ways we can do this with this fraction. Flip the fraction over and change the sign. Or it could just be neither. So let's take a look. If we have 0.2x, that one works. Actually, we're not going to circle. We have to actually write for each one. So this one is going to be parallel. For the next one, we have -2. That is neither or neither. Because perpendicular to this should be switching instead to 5 over 1 and then switching it to negative. So that's going to take us then to part C, which is also going to be neither or neither. Because this would have to be -5 in order for this slope to work, to be perpendicular. So for option D, this one is perpendicular. Because it is -5, which is the opposite of positive 1 over 5. 2 is the next one for E, so this is not going to work, so this is neither. And then for our very last one, we would put this into slope-intercept form. So we would subtract 5x from both sides. And if this was in slope-intercept form, it would be y is equal to -5x plus 3. So this one, because it's -5, is also going to be perpendicular. So there's that. That's going to bring us to question 2. Main Street is parallel to Park Street, and Park Street is parallel to Elm. So let's talk about these streets here. I'm going to draw a couple lines. If I have Main Street, that's parallel to Park Street, and Park Street is parallel to Elm. So this is Main, Park, and Elm. Now, Elm is perpendicular to Willow. So I'm going to draw a perpendicular line on Elm, and this is going to be Willow. Now, that's W. So how does Willow compare to Main? And these don't necessarily have to intersect, but I did make it so that they intersect. And the visual is always helpful, so if you really need to draw one, please do. Willow is going to be perpendicular to Main. So if some lines are parallel, whatever the relationship is of just another random line to one of those lines will be the relationship to all of them. So if Willow was parallel to Elm, it would be parallel to all of these. But since it's perpendicular to elm, it's going to be perpendicular to all of these. So we would say willow is perpendicular to Maine. And that's our answer. That's going to bring us then to question 3. The line, which is the graph of y equals 2x minus 4, is transformed by the rule xy becomes negative x, negative y. What is the slope of the image? So negative x, negative y um, doesn't really do much here because it just creates negatives of both of these sides. So what we're actually doing is almost like a 180-degree rotation here. Um, so the slope of the image is exactly the same. The slope of the image is the same as the pre-image. So we can even check this by plugging some numbers in, and we can use, uh, let's see, if we used, what's the point that works here? Oh, we could just use the y-intercept probably. So we would have, yeah, 0 comma negative 4, which would become 0 comma 4. But yeah, it's just a reflection across both axes, which kind of just makes a 180-degree rotation around the center. So yeah, sorry, it took me a second to realize in my brain because I knew that the negative and the positive 4. So yeah, it's gonna be it is gonna be exactly the same. It's a 180 rotation around the origin. For a second, I was thinking it should have been around the line itself or where that axis intercepted the line, so the y-intercept, but it's around the center, so it actually does make sense for that to work. So sorry that took me a second there. I had a little brain fart. Okay, so then question 4. Select all equations whose graphs are lines perpendicular to the graph of 3x plus 2y equals 6 and show how you know by finding the slope of each line. Okay. Now, if we find the slope of this first one, we can do that by putting this into slope-intercept form. And so that would be done by subtracting 3, I wanted to do this in red, subtracting 3x from both sides. So you'd have 2y, negative 3x plus 6. And we would divide everything by 2. So you'd have negative 3 over 2x plus 3. So we want this slope here is negative 3 over 2. So the perpendicular slope would be positive 2 over 3. Now, we do also, since it's negative 3 over 2 and we want it to be 2 over 3, we would basically swap the positions of the x and the y coefficients and then change the sign on one of them. And that should give us that same effect of the 90-degree rotation. So we wouldn't want to have 3 and 2, but for something like B and C on here, where we have 2 and 3 instead, that could work. So here, this slope, if we were to do a shortcut, the shortcut here would kind of be change the sign of the x coefficient and then divide by what's in front here, because that's the operation that we're really doing, is to change the sign by subtracting or adding it from both sides and then dividing by the coefficient in front of y. We can kind of just ignore the constant or the intercept here because that doesn't have an effect on slope. So this would become negative 3x, so y would be negative 3 over negative 2, so positive 3 over 2x, and then 4 divided by negative 2 would be minus 2. This would be not that one. This one here, we would have 3y is negative 2x plus 6, so y is equal to negative 2/3 x plus 2, negative 2/3, but we want positive 2/3, so not going to work here either, but it will work with c, because you can see the coefficients themselves are the same, so we'll end up with 2 atop the 3, but one of these is negative. And so when we do that, it's going to create a negative divided by a negative, and we'll end up with a positive. So this one we would end up with y equals positive 2/3 x, and then we would have 8 divided by negative 3, so minus, just going to put minus 8 over 3 here. So that means this one is perpendicular. We want the positive 2/3. Now for D is also perpendicular because we have the slope of positive 2/3. E, we know, is not an answer for the same reason that it's negative 3 over 2. And we could see its position pretty easily. Actually, let's do this. Get the whole thing here. And in F and G, we can also see their slopes pretty easily here, positive 2 over 3 and then positive 3 over 2. So we want the positive 2 over 3, so that means F is also an answer, but G is not because that's 3 over 2. And that's going to be it for the front page. We're going to switch to the back. So the last couple questions from this unit. Since this was our last lesson and we're ending our unit here. So we want to match each line with a perpendicular line and then show how we know. So I'm going to identify the slopes of all of these lines. And I can see I have 1/5, 2/3, negative 2.5, and then I have a couple other things here that don't quite match. So let's actually look at some of these fraction ones, but you'll see what we've got. Oh, excuse me. So negative 2.5, if I was to turn this into a fraction, just because some of these are fractions and some of these are decimals, negative 2.5, this would be the same as negative 5 over 2. And if I did 1/5, this would be 0.2, and 2/3 would be 0.6 repeating. So we want to match them with perpendicular slopes. So a perpendicular slope for number 2 over here is 1/5. So the perpendicular slope would be negative 5 over 1. And we're actually going to have to do the slope of the points of A and 1, and we're going to rearrange B. So let's do the rearrange first into slope-intercept form, and then I'll actually excuse me again, I'll calculate the slopes between the points on A and number 1. So we would have negative 5y equals negative 2x plus 10. Divide everything by negative 5, and then this would become y equals 2 over 5x minus 2. So the slope here is 2 over 5. This one, because of the slope right there, this is going to match up with number 3, and I can see that already because 3 was negative 5 over 2, and the slope here was positive 2 over 5. So I could already see that one. All right, so in order to do the slope, I'm going to show a variation of the slope formula between 2 points, but the slope formula between 2 points is y2 minus y1 over x2 minus x1. And if you are comfortable doing it this way, please do it that way. I like to show a different variation where I do the subtraction first and then put my answers into the correct places instead of trying to place them into this formula. And so in order to do that, it's almost like making it into a table, but I stack up my values here and then I subtract them going downwards. So 3 and 1. And when I subtract going downwards, that just makes sure that my x subtracts with the other x and the y subtracts with the other y. And then I just have to be careful to put y over top of x. So if I'm going to do here for minus 1, that's going to give me 3. And if I was to do 1 minus 3, that would be negative 2. So in order to do y over x, this is 3 over negative 2. So that one is going to be the opposite of the 2/3, which is C. So 1 is going to match with C, which means that 2 should match with A, but let's just double check this slope over here. I'll line up the 9 and the 19. 12 minus 9 is going to be 3, and minus 19 is going to be negative 15. So this is x and y, and that means, ooh, that's a messy y. Gonna bother me, sorry. So that means we would do negative 15 over 3, and that would reduce to negative 5. Negative 5 is going to be the opposite of positive 1 over 5. So yes, this one here would match up with number 2. That's going to bring us now to question 6. We have the graph of y equals negative 4x plus 2, and it's translated by a direct line segment AB shown. What is the slope of the image? Well, this is just finding the slope. No, actually, yeah, finding the slope, but based on the translation. So we're not finding the slope of the translation. And a translation will not affect the slope because every point is being moved in the same way. So the slope of the image is the same as the pre-image. And then that's going to be the negative 4 attached to this x here. So the slope of the image is the same as the pre-image. M equals negative 4. There we go. Because a translation will not alter the slope. A rotation will, and if you have an uneven dilation, so a different scale factor on each axis, that will change it. But overall, a stationary dilation will not. And a reflection will also change it. So Basically, translations are safe and pure dilations are also safe for maintaining your slope. Okay, so question 7 is similar to a previous one that we just had with all those slopes and matching up some of the lines. But in this case, we're actually looking at matching matching slopes with um, we want to just find a bunch of slopes. So I'm going to show the same method that I showed of stacking and subtracting, just so that I keep myself on pace here. So A, B, C, D, and E. I'm going to label each of these and just show my work for each one. So A, B, C, and then we'll do D and E. And for each one, we're going to start with the 4 comma -1. And then for each of the other points, A through E, I'm just going to write those underneath. So starting out here, for -1, I'm just going to write that for all of these first. For -1, for -1, for -1, for -1. Okay, now starting with, I'm going to do the other ones here in blue. So -2 comma 2 is X, this is Y. If I subtract downwards, 4 minus a -2 actually makes a plus +2. So this is going to be 6. And then -1 minus 2 makes -3. So I would put -3 over 6 because I'm doing the y over the x. So -3 over 6. -3 over 6, and that does become -1/2 when we simplify it. So this would be on the line. Now, I guess I didn't really explain why we're just finding the slopes of all these points, but it's anything on the line, and the specific line is -1/2. With a slope of -1/2 that goes through 4 comma -1. There's another way to do this instead of finding the slope between each of these sets of points, and that would be to set up the point slope form of this equation and plug in the x and y values. But it's essentially the same because that's actually where the point slope formula comes from. It comes from what we're doing with finding slope. So back from that detour, let's go with 0 comma 2 here. So 0 comma 2, we're going to subtract downwards. 4 minus 0 is 4. -1 minus 2 is -3. This is -3 over 4. That is not an answer, or a same slope, so it won't be on that line. Okay, and then for C, this is 4 comma -1. This is the exact same point, so you're actually going to get, when you subtract 0 and 0, so it's technically on the line because it's the exact same point. Um, so that's up to you, but I would maybe not consider this to be an actual answer, because the slope doesn't work. It works out to be 0, but we're also dividing by 0, and you can't divide by 0. But you could also argue that 0 divided by 0 should be 1. So, I don't know, I'm of two minds on that one. But D, if we have 0 and 1, let's actually subtract this one. 4 minus 0 would be 0. -1 minus 1 is -2. So this would be -2 over 0. Not going to be an actual answer here. And then the last one, -3 comma 8. 4 minus negative 3 is 7, and 1 minus 8 is negative 7. So this one here, I didn't do one of these wrong, did I? No. Oh, I'm sorry, this is not negative 7. This is going to be negative 9. So negative 9 over 7 is not going to create negative 1/2. So, yeah. Oh, oops. I did do this one wrong. Sorry. I did D. I was like, something's wrong here. I thought D was actually going to give me this answer. 4 minus 0 is 4. So if you caught that one. And negative 1 minus 1 is negative 2. This makes negative 2 over 4, which does become negative 1/2. So I was wrong about that one. D is a correct answer. I was like, I did this question earlier today, and I know I got a different answer. There we go. That makes more sense. Okay. That brings us to the last question. One way to define a circle is that it's the set of all points that are the same distance from a given center. How does the equation x minus h squared plus y minus k squared equals r squared relate to this definition? And draw a diagram if it helps you explain. Well, I definitely am going to draw a diagram. I'm going to draw 2 points. And we're going to talk about how to find the distance between these 2 points, because that is where this formula comes from. So in order to find the distance between these points, we would want, oh, it's not quite going to be a, in order to find the distance between these 2 points, we would want to know the vertical and the horizontal change, because we want to actually set this up as a right triangle. Mine's just very wobbly. So we want this to be a right triangle, because if we're trying to find this here, or we know we want that to be a specific number, or check if it's a specific number, we want to use the vertical and the horizontal. So these would be like my C, and then I would have my A and my B. And we can just use the Pythagorean theorem and go from there. The problem is these points, if we're on the coordinate plane, we're going to have to give them locations. So we would have to, for our vertical change, just like in slope, we would normally have y minus y. So you can think of vertical change here as like y2 minus y1. And for the horizontal change, we can think about this as like x2 minus x1. Now, in order to actually find our value of c, we would have to do a squared plus b squared equals c squared. So we're going to do a little bit of substitution first, though, because we can actually give these values. So we're going to call this point here x comma y. And with a circle, the center we call h comma k. And we're always checking, is something a specific distance from the circle? So in this case, then that creates, instead of a squared being y2 minus y1, this can be y minus k. And then instead of x2 minus x1, this can become x minus h. So now we can kind of do some substituting for a squared, b squared, and c squared. But if this was a circle, this would be like r for our radius. So if we originally had a squared plus b squared equals c squared. And I guess I mislabeled these a little bit. I guess I want the vertical to be b, but it's okay. A squared plus b squared equals c squared. So it's just going to look a little out of order. But that would then mean that a squared, well, that's got to be then one of these squared. So that's got to be y minus k squared. And then b squared, we said, was x minus h squared. And c, that should be the same as the radius, so that should be radius squared. So we're going to say it comes from using coordinate values in the Pythagorean theorem to find the distance between 2 points. And in this case, those points are h comma k and x comma y. And that's it. It comes from using coordinate values in the Pythagorean theorem to find a distance between 2 points. So yeah, thanks for sticking with me through some of my brain farts here today. I'm yawning, so I'm pretty tired. I'm a little bit worn out, but hopefully my explanations made some sense. And if not, please always ask questions in class. And I'm sorry if I made any mistakes. I am pretty exhausted. So thanks for sticking with me. This is the Unit 6, Lesson 12 cumulative practice problems for illustrative math geometry.